Hey everyone, welcome back for the last afternoon of the AusCERT conference. So just a reminder, you've all probably heard it before, Chrome is the recommended browser to use. It seems to be the most stable, and if you do have any issues, guys, just refresh the page or reload the page seems to be the way to get most problems resolved. So the last two presentations we have today are actually pre-recorded, and the presenters for this next coming presentation are not not around to share any kind of questions and answers. So unfortunately, we'll be taking no questions for this next presentation. So without further ado, I'm going to pass it to Ayman Sagy and Willem Mouton on their presentation, Orchestrated Containers and How to Hack Them. Thanks very much.
Everybody, welcome to our talk, Orchestrated Containers and How to Hack Them, and a little bit of securing them. My name is Willem Mouton. I'm here with my colleague Ayman Sagy. We are both security consultants at CyberCX. We previously were with Sensor Security before joining the CyberCX group. The most important thing that you need to know about the two of us is that we really enjoy any form of technology, and most of all, how to break and misuse it for nefarious purposes. So why this talk? Well, it's pretty simple. Containers and orchestration is gaining really in popularity. There's various implementations across all major cloud providers, as well as the smaller players. It's available virtually on all platforms. You can even get your own Kubernetes on your Raspberry Pi, which I found, to be really interesting. We started running across this more and more on our pen test engagements. So we started to dig a little bit deeper. Obviously, we started to like it, and we thought we'd share some of that with you. The big thing with containers and orchestration, specifically Kubernetes, for example, is that implementations tend to become quite complex. And I'm talking now about personal experience. There's a bit of a learning curve in getting to grips with everything to do with it. So, this is not a talk about, the intricacies of containers and Kubernetes, but it's probably useful to have a, 5 minutes or less than 5 minutes background, on the different components that we might be looking at today. I'm going to start with containers, and that little meme there at the right says about everything. If you're a developer, if you've ever written a piece of code and had to explain to people that, yes, it does work on my machine and not, and I can't understand why it's not working on theirs, then you would really appreciate containers. Now, we've got a little picture of Docker here. Docker is certainly not the only containerization technology out there. There's quite a variety of them. But we predominantly work with Docker and play around with Docker, and so far during the course of our assessments, we've been predominantly faced, with Docker as a technology. So in the spirit of Docker, we took this little definition straight from their resources, and it basically goes along the lines of a container is a standardized unit of software that is packaged up in code and all its dependencies so that the application could run quickly, reliably from one computing environment to another. And that is the really cool part with Docker, right? If you've ever had an application, let's take, for example, a Ruby application with all its dependency hell on Linux, Docker really makes your life really easy. Okay, so that's just a little bit of a quick overview of the base Docker infrastructure, but it's pretty much similar across most containerization technologies. You've got your bare metal infrastructure that is running on your operating system, the Docker daemon, which basically controls the running containers, and then you've got your individual containers, which is the applications that were containerized running on top of the daemon. A lot of people initially, when you first see, containers, you might, think it's nothing more than a lightweight virtual machine, but that's not exactly the case. Most of the, virtualization happens in user space. It's pretty much exclusively, Linux orientated. You can run Docker on other operating systems, the daemons or the containerization on other operating systems. But, we've mostly only seen Linux applications be, containerized. It's extremely, handy, like I mentioned in the previous slide, to be able to wrap your application in a digital bubble, and, makes it really easy for distribution. The really cool thing about it is that there's multiple online sources. Like we said, this has been gaining in popularity, quite fast. There's a lot of official and unofficial sources, on actually downloading and installing pre-built, pre-baked Docker images. Docker Hub comes to mind. And, while that is super convenient, it does come with quite a couple of drawbacks. I just mentioned images can be baked and reused. That is really, that's a really awesome feature, specifically if you're in an agile environment and, you want to have dynamic deployments and all of that. It is pretty much awesome. Also, the other really cool thing about containers is that they're non-persistent. If something goes wrong, you just wipe it and you just boot up a new one. Now, with all of the cool things, there's a couple of security considerations that needs to be taken with these. And some of them are maybe, when we say them, it sounds like it's obvious, but you do see that, people tend to forget about that. As with traditional security best practices, we always harp on about, patching and configuration issues. That holds true for Docker as well, or for containers as well. But not just the containers themselves. You've got to keep your host operating system up to date, the actual containerization daemons that deals with your containers. But don't forget the actual containers themselves, right? Yes, you can pin to latest tags and things like that. But a lot of people just pull down a base image, build of a specific version, build on top of it, and then they reuse that. The problem is that just like a normal operating system, your Docker operating system for your specific container, can become out of date and contain security vulnerabilities, right? So you need to keep a good eye on that. Also, sensitive data can be left on on these containers. People also tend to forget that a container is still a little operating system, and it can be breached, and any data that's stored in there is not necessarily inherently secure just because it's in a container. You need to, just like in normal in traditional security, you need to watch out for overly permissive permissions. We do find that a lot of containers actually run their applications as root within the container. Also, remove any unneeded executables or functionality. It's always a good idea to build off the base, the bare bones base images. But we do find that for convenience sake, people tend to build a lot of containers off of fairly bulky base images. For example, a straight up Ubuntu image, and that allows an attacker that potentially compromises those containers with the ability to quickly load whatever tools they need on there, or it actually comes pre-baked with quite a lot of useful tools. Also, you need to keep ahead of what are you exposing with these containers. Again, traditional network security does apply. You only need to expose what is required. And again, we do see that people tend to forget that because it's a container, and that they see it as something different from the traditional security controls. This is just a quick little screenshot to show that we in the last couple of years there has been some quite severe vulnerabilities in Docker itself. This is just an FYI. Next, Kubernetes. Now, if a container is a really nice way of packaging it, applications, Kubernetes is a really nice way of actually orchestrating and maintaining and getting a grip on a fleet of these containers, right? It's essentially at its core, it's a really big state machine to manage, deploy, keep track of, kill, and restart different containerized applications. It basically consists of 5 major moving parts: your nodes, pods, services, deployments, and ingresses. Now, your nodes are basically the host servers that that run everything. The pods are a group of one or more containers and specifications for how to run them. They all run within a shared context. It's basically the building blocks, for your Kubernetes, application deployments. The deployments itself is basically a description of the desired state of the application, and Kubernetes takes the desired state and makes sure that it happens. Right, it keeps it the way it should. It's almost like the old playbooks that we used to use in for example Puppet, Chef, or Ansible. Services is just a way of extracting the application and exposing them as a network service. You can think of it as plumbing. The communication between pods themselves, back end, front end, as well as to the outside. Using ingresses into and out of the Kubernetes cluster. And then I just mentioned ingresses. Ingresses is a simple way to manage access to your servers. It can provide load balancing, SSL termination, and a host of other features. It's almost like firewall rules, almost like AWS security groups, but it's useful to keep an eye on these suckers. Right. So just as with containers, there's a couple of security considerations to take into account. Right. Again, security vulnerabilities, patches, and misconfigurations. Now, you need to make sure, again, that you keep your orchestration services up to date, as well as any plugins or additions that you've installed in them. Same with the operating systems that you run them on. Overly permissive access rights, do tend to sneak in quite a bit inside these deployments. Just like I mentioned, there's a bit of a learning curve. It can become quite complex. So we do see a lot of access right issues and authentication issues within these Kubernetes deployments. Also exposed administrative interfaces, and I don't just mean to the internet itself. You're going to see in the demo a bit later on, how some of these can be abused. And then also network exposure, internal, external to the internet. It's something to really keep, to wrap your head around what you're exposing, when you're exposing it, and how you're exposing it. Again, this is just a little FYI to show that even Kubernetes does suffer from some vulnerabilities, maybe not as red as the previous ones we've seen from Docker. Now with that, I hand you over to my brilliant colleague, Mr. Ayman, and he's going to take you through some hacks that we've been playing with on some of our assessments. Over to you, Ayman.
All right, you've heard enough. Let's see some action. I'm going to show you a simulation of an attack against Kubernetes, where the attacker will start attacking a container in a pod and move their way to compromise the host node and cluster. Let's first have a look at our architecture. We have here a Minikube cluster, and Minikube is a lightweight single node Kubernetes cluster that can be installed in a simple VM. In the Minikube cluster, we have a pod that is running a container, and the container exposes a web service which is running a vulnerable web application that the attacker will exploit to gain initial foothold. Okay, let's get straight to the demo, and hopefully it will not break. Let me just switch screen here. Here we have the attacker view, and they are trying to attack a website. Let's say the AusCERT website. Not the real one, of course. I'm not saying that the AusCERT website is vulnerable. Well, I can't say for sure because I have not tested it, but that's the assumption. Maybe some foreign attackers tried to break in and hopefully they are not successful. This is just a local copy of a clone of the AusCERT website that I created for the purpose of this demo, and perhaps to reuse it in future social engineering, but with a more subtle and elegant URL than this. Anyways, jokes aside, I added a vulnerable PHP code to that local copy of the website, and now the attacker is going to exploit it to gain remote code execution. As you see here, the attacker runs arbitrary PHP code on the website and gets a shell. They get a shell in the Kubernetes container, but they don't know that yet. All the attacker knows is that they got a shell on some web server. So they start doing some enumeration to get understanding on that web server. They look at the host name, notice that the host name is Minikube, which suggests Minikube cluster. The attacker drops in a shell for further enumeration. They look at the host's IP addresses and sees some localnet addresses, which also aligns on what we see on what we have in Minikube. The attacker looks at what services are running on the local addresses. They see a bunch of them. Something's running on port 8443, which could be listening, as we will see in a moment. The attacker looks at the mount points and finds a Kubernetes volume, which will contain the service account token that is used by the pod to interact with the Kubernetes API server. If we look at this file here, let's have a look at this volume first. We see there is a token and a certificate and namespace file. This token holds a JSON web token, JWT, right here. The attacker takes a look at the locally running services like that one on port 8443 we've seen before, issues an HTTP request with curl, and they get a JSON response that looks like from Kubernetes API server, and it says we don't have access because we are anonymous. The attacker can try to authenticate using that JWT token they just found. So the attacker uploads the kube control utility. The attacker has now identified, which we will discuss now, the attacker has now identified that they are running in some container and discovered the Kubernetes API server location on the port 8443. They also found a JWT token for the service account that runs the container. Armed with this information, the attacker can start attempting to query the Kubernetes API server for further enumeration of the cluster. And for the attacker's convenience, they upload the kube control utility, which is a standard Kubernetes tool that can query or perform various administrative functions. There we go, it's uploaded now. The attacker drops back in a shell and runs the kube control utility. So now the attacker can pass that JWT token to kube control and the URL of the API server to perform some basic enumeration on the cluster. For example, the attacker tries to get the running pods on the cluster. It doesn't work. The API server says you don't have permission, and we can see that our service account is called SA demo. So the attacker tries something else, for example, enumerate cluster information. Instead of get pods, we see cluster info here. Also no access, it doesn't work as well. So our service account is not fully privileged. It does not have permission to do everything, but there was one dangerous permission granted to that account, which is the ability to get secrets. As we see here, the attacker tries to get secrets, and secrets is like a vault in Kubernetes cluster that stores secrets, which can be username, password, credentials, keys, or any other sensitive information. The attacker discovers that there's a secret called kubeadmin, and they try to dump the secret details by outputting it in YAML format. And we see here we get a username and a password in base 64 encoding. Actually, that's not the one I wanted to show you. We wanted to dump the kubeadmin secret. So we get here a username and password in base 64 encoding. The attacker decodes back the username and the password. The attacker gets a username called Docker user and a fairly good password with upper lower cases, alphabets, and some numbers as well. The attacker can then attempt to log in with these credentials or spray the password elsewhere. So they try to log in, for example, through the exposed SSH interface. In a new shell, the attacker tries to SSH using that Docker user and the password they just decoded. And they successfully log into the Minikube node. The attacker is now in the cluster node itself that is running the pod, not the container from this shell. So they can try to again enumerate all the information that they couldn't do before. We see here that we have kube control utility because this is the node, it's part of the container and it's installed as part of the Kubernetes installation. The attacker tries to list the running pods. They see there's a pod called AusCERT demo pod. Let's try to list pods in all namespaces. See a bunch of them. Enumerate cluster information, for example. And we see here Kubernetes services running on the local interface. The attacker looks at the deployments, discovers a Kubernetes dashboard deployment, and the Kubernetes dashboard is a web GUI to interact with the cluster instead of running all these kube control commands in the command line. The attacker takes a look at what services are running here. They see something Kubernetes process on port 8001, which is probably the Kubernetes dashboard. The attacker gets something else from the secrets, gets the JWT token used to log into the Kubernetes dashboard, and notice that we are now enumerating secrets in a different deployment, the Kubernetes dashboard, not the AusCERT demo. So this was not this would have not worked in the previous shell that we were just in. So the Kubernetes dashboard is running on the local host, which is not remotely accessible to the attacker. What the attacker can do is they can set up an SSH tunnel using the same credentials that they discovered, the SSH credentials. The attacker will forward the traffic from their machine to the local host of the remote machine. We again use the same credentials here to set up the tunnel. Now the attacker can try to access their own local 8001 port, and it gets forwarded through the tunnel to the remote machine, to the localhost interface of the remote machine, and we see indeed that we can access the Kubernetes API. The attacker tries to access the full URL of the Kubernetes dashboard, and they are presented to login. We can now log in with that JWT token that we've just extracted. And the attacker gets in to the Kubernetes dashboard. They can see all the cluster information that we've previously seen. And yeah, that's it. Let's get back to the slides. So what was wrong with this setup? We had a vulnerable web application. We had some misconfiguration in Kubernetes where we assigned the dangerous permission to the service account that runs the pod. There is also an increased attack surface with the SSH interface being exposed. These are the commands that I used to create this vulnerable setup. The first one here we see creates a role that has the ability to read the secrets, and the second one creates a role binding which effectively applies that role to a certain account, which is the SA demo service account. And here is the YAML configuration of the pod. We can see that it runs under the service account SA demo, which has that role. Other permissions to watch for could be the ability to create pods. If the attacker can create pods in your cluster, they may provision crypto mining pods and waste your resources. Wildcard can give permissions to all verbs and resources. So for example, you can you can create a role that has the ability to list everything. The verbs can be things like get or create or delete, and resources can be pods, deployments, secrets. So hardening should be an essential part of your build standard. There are CIS benchmarks for Kubernetes, and there are tools that can help you check and apply these benchmarks, as we will see shortly. Some brief points to note about the pod isolation. This will make it harder for the attacker to break out of the container to the host node. If you set privilege to false, a privileged pod has access to all devices on the host and similar to any process running on that host rather than being in a restricted container. Allowing host network will share the host network with the pod, giving it access to the loopback interface and any services listening on the local host. Host path lets you mount a path on the host inside the pod. So again, this could be something where the attacker can escape out of the container and access resources on the node itself. Allow privilege escalation will prevent changing the effective user ID. This will break any SUID binaries. So if you have a container that needs to run SUID binaries, be careful with that. Read-only file system will mount the container file system as read-only, which will prevent the attacker from uploading tools as we saw in the demo. Run as can let you run the container as a non-root user. Some additional hardenings to further lock down the container and make it more difficult to escape out could be configure SE labels, SE Linux labels, or AppArmor profiles for your containers. You can also filter or restrict the system calls a container can make using seccomp, and you can refer to this resource for additional information. Okay, let's have another demo to see those tools in action. Okay, the first tool I'd like to show you is Kubernetes RBAC Audit, which can help you identify such dangerous permissions that are provisioned in your cluster. And it works by simply exporting the current roles and permissions in JSON format and then running a Python script against those JSON files, which will perform its analysis and flag out any permissions. As you see here, it says that there's a role called secret reader that has the permission to list secrets, and this role is bound to the SA demo service account, as we've seen in the demo in the lab. So this can help you identifying such permissions simply and acting accordingly. The next thing I would like to show you is CubeSec, which is a security analysis for Kubernetes resources. It can be installed in multiple ways. I have it here as a plugin to kubectl. So kubectl has a plugin management called Krew, K-R-E-W, and I have it installed as a plugin to kubectl where I can run it against a certain pod. For example, let's try to scan the AusCERT demo pod. Running it like that, kubesec scan, and then give it the pod. It scans the pod and gives us a finding about sharing the host network. It says processes in the pod can communicate with the host's loopback adapter. Very straightforward. The other tool is kubebench, and you can simply run this to perform the CIS benchmarks. Kubebench runs the CIS benchmarks and reports back the findings. As we said before, these hardenings should be standard part of your build procedure, and hopefully that was very straightforward and simple. Let's get back to the slides. A couple of other relevant talks by our COO, Mari Goldschmidt. I'll hand it over to Willem here to tell you more about this.
Like you mentioned, there's a couple of talks by one of our colleagues named Mari Goldschmidt. Now, securing containers and servers and orchestration is quite a difficult task. Yes, the CIS benchmarks and some of the tools that Ayman showed us now is a really good start, but it is only just a start. There's a whole lot more that you can do in terms of runtime security, in terms of vulnerability scanning of the actual containers themselves. So if you want to dig deep into that, I suggest to look up some of Mari Goldschmidt's talks that he did at RSA in San Francisco in 2019. It could be really useful to you. That said, we're almost at the end. And just before we go, I just wanted to remind you, a couple of key highlights that you need to take into account if you're running Docker or container or Kubernetes clusters. Just going to reiterate, make sure that you maintain your patch levels, both for hosts, services, and containers. Audit your configurations and permissions quite regularly. Remember that in the end, you know, with containerization and orchestration, it's primarily everything is software. And as with any software, pieces of software, bugs and misconfigurations do tend to creep in. So keep a continuous eye on that. And then don't forget about ingress and egress. We've spoken about ingress, but a lot of people also forget about egress. In Ayman's demo, he wouldn't have been able to connect back out from the compromised container if proper egress controls were in place. So with that, I would like to say thank you for watching. And if there's any time, feel free to ask us questions. If you don't want to ask us questions right now, if you've got any questions, please look us up. Our email addresses is up at the top. We love interacting with everybody. So if you've got any questions, feel free to ask. Thank you so much.